So the CIT tutor, I strongly recommend you talk to them if you get stuck. If you need help catching up, or if you are caught up but you're just having trouble on a homework assignment, yeah, you can ask me, but also you can talk to the tutor. So their name is Jairus White. Their email address is jwhite@rose.edu. They're located downstairs in room BS 131. Their hours are Monday, Tuesday, and Wednesday, 9:30 a.m. to 5 p.m. Lots of time. And then on Thursday, in case you need evening hours, which is right during our time, but anyways, 6 to 8:30. So you could rush down there right after this class, right? If you needed help from them. Strongly recommended. Good tutor. I've heard nothing but joy from people who've gone to see him. So if you're stuck on something, send an email or drop by. Also, this site has been recommended to me. I used to use one called Codecademy without the A, codecademy.com. I thought it was a pretty good website. I liked it a lot. I sent a lot of people there. And now that I poke around in it, it sure does seem like you have to pay to use it now. Maybe that's not true. Seems that way. So, another one, sololearn.com. You can sign in with your Rater, your Rater email address, and then go to courses. We ought to be able to find a Java tutorial. It's way good for catching up. I mean, we pretty much all know what variables are, right? And stuff like that. But still, by the time we get to arrays, and methods and stuff like that, I would zero in on Module 3 and Module 4 if the rest of it looked pretty good. And I don't think you have to do them in order, unlike Codecademy, right? So, recommend looking at that as well. What did I say they were called? Unit 3 and 4. Go look again. Modules 3 and 4. I want the exact term. Yeah. Assuming you already know what variables are and stuff like that. And if you don't know what those are, it's going to be a rough course. But still, take advantage of the tutoring. Take advantage of Solo Learn. If Solo Learn's not good enough for you, you can poke around on other sites. There's a lot of places where you can get Java information. And talk to me about it. Alright, so what I'm going to do is we have another lecture that I recorded for the online students. Lecture C, the car class and references. Oh, Simon pointed out, and it was true, that Lecture B referenced a homework box that wasn't open yet. So if you uploaded the RAT UML and the conversion class that it mentioned to the B drop box or the homework 1, please go ahead and upload it into homework 2 as well. And if you didn't do those because you didn't find them, I totally understand. I wouldn't have done them either, right? So, but now you're expected to. So if we go and take a peek at what the homework assignment is, the first thing it's got is it doesn't have a link to the video. Well, we'll get that straightened out. Let's take a look at the documentation. Write a UML for the RAT class, just like we did in our demo. And we did do that, right? In the homework assignment, in the video. For B, we did UML. Thumbs up. I'm seeing some people nod. All right. So, what's the RAT class? Well, if you didn't watch the demo, you're going to need a copy of the RAT class. And so that is provided in the next homework assignment. I will modify the homework assignment to have the rat class in it in case you did not do it. But Dropbox C asks you to modify the rat class. Or excuse me, homework 3 asks you to modify the rat class. So we better take a quick look at what the rat class is. And we could even rewrite it, but it was part of the lecture, correct? Rat class sounds real familiar. All right. So here's the rat class. It's got a couple of members: weight, age, and growth rate. And it's got a grow member that every time you call grow, it increases its weight and its age. It's got some mutators. Mutators being the things that modify the values of the private variables. These are all methods. These are all member variables. They are known as instance members, because you have to have an instance. You have to have an object in order to call them. It's only the ones that are marked static that you can call without having an object. And it has a constructor. And the assignment was to add an equals method. So I like seeing toString methods, and I like seeing equals method in classes. ToString methods are good for debugging purposes, and equals methods are good for checking the equality, because you just can't compare two references. So let's go ahead, or at least I'm going to, go ahead and go into NetBeans and do a little bit of demonstration like that. It's going to be a much more trivial example than that. As you see, this homework assignment also relies on stuff from that rat class lecture. So if you haven't watched it, be a good thing. But if you look at the homework and you get it all without watching a video, okay, because I did say it was optional. But I'm going to call this lecture D, just because the lecture C is the one that I'm going to want you to watch. So don't be confused by the fact that this is only the second class and we're calling it lecture D. So if you're using NetBeans and you didn't tell it otherwise, it's going to add a package statement. I asked y'all to remove the package statement and then let it make the change required to get that to work. So up here, we see a red error message. This says incorrect package. This package is just a subdirectory of the source code directory that this is in. But it stops me from being able to compile it in TextPad, which is what I do when I'm grading these, rather than load each one into NetBeans, which takes considerably longer. So you can move the class to the correct folder. That's what I would like for you to do. All right, so I'm going to make a class. Pretty dang simple one. How about a class that has a first name and a last name? Or maybe even simpler than that. It's got a name and an age. So I'm going to call it person. And I should be putting these, each additional class in its own file. Them's the recommendations, but I'm not gonna. You can only have one public class, and that's the one whose file name has to match the file name here, right? The name of the class has to match the file name here. So when you create a class, don't put a space in its name. And if you're copying and pasting and stuff like that, and the public class name winds up being different than the .java name, fix it. All right, so int age, and then string name. Now I'm going to make a mistake here because I saw some of the online students who've come and asked me for help. Don't just blindly accept the suggestions that NetBeans gives you. My prior students have already heard this, but okay, so say I type in string space name there. And if you're a C++ developer, you may be used to the idea that you could create a string with a lowercase s, but you had to go and add an include statement. Anyways, you go over here, create class string and package. Well, that'll make the error go away. But now we've completely broken our project. The string's not going to work at all. We have created a brand new class called string with no functionality. Not going to be able to store any data whatsoever. I should go and I should delete that file. I'm not going to take the time to. So simply because I had an error in capitalization, and then I went in and I chose, fix the error and create, never do the create class option of the fixing of the error unless you're absolutely sure that's what you want to do, right? You can take advantage of that create class thing, but until you're sure that's what you're doing, don't pick it. All right, I'm not going to add the getters and the setters for this part of the lecture. If I wanted to, I could use the refactor, or I could do so by hand. I really shouldn't be skipping that, but I'm gonna, because I want to get to the part where we use the equals method and the toString method. So I'm going to create a person. Person P1 is equal to new person. Parentheses and parentheses. We have created an object and we have stored that object's address in the P1 reference variable. P1 is not the object, it points to the object. Right? Just like you have a house and then you have a house's address. And the mailbox, contains a house's address. The mailbox is not the house. Or you have a street and then you have a street sign. You can have multiple street signs pointing to the same street. Right? You can have multiple references to the same object. Person P2 equals new person. And now we're going to assign some data. P1 dot name equals Fred. P1 dot age is equal to 30. Then I'm going to do P2 dot name equals something and P2 dot age equals something. P2 name is equal to Barney. And remember, you don't have to type this stuff. You can just watch if you like taking notes in a different way. P2.age equals 31. Now I want to see if these people are the same. They're the same person. So, this is not going to work. If parentheses P1 equals P2, tell you what, let's simplify this. System.out.println same question mark plus parentheses P1 equals P2. Right, you see what that's doing? This is doing a comparison, and then it will print the result of that. And it's going to say no, they're not the same. It'd be a good time to run it now. I'm going to remove some spaces and stuff like that so I can try to keep as much of the code on the screen as possible. It's going to make it a little bit harder to read. There. All right. We're ready to run, and it's going to say that same question mark is equal to false. Hope that makes sense. I'm just printing out the result of that. It is going to be a Boolean result, which is equal to true or false. I could have written an if statement, right, and then, had an if and then print, yes or no, something like that. I'm going to build my project, or I could hit the hammer and broom. And then I'm going to click the green arrow. No, they're not the same. Good. I'm glad. What if we make them the same? I'm going to change Barney to Fred. And I'm going to change person 2's age to 30. Now they look a lot more similar, right? If we had a social security number field or something like that, then, if those two things are the same, we would say that they're the same data. It's still going to say false. The reason it says false is that if you do this comparison, it's not checking the data. All it's doing is checking the addresses. And the address of these two objects is different, no matter what the content is. This created one house. This created another house. The houses are absolutely identical. they're blue with 2 bathrooms and 4 bedrooms and whatever. Doesn't matter that they're absolutely identical. They are at different addresses. So when we check them, all we're doing is checking to see if the addresses held in the reference variables point to the same thing, and they do not. They point to 2 different houses. Here's one way we could get around that. Oh, and by the way, that's why you cannot compare strings in that fashion. If I did this, string S1, comma S2, and I did S1 equals A, end quote, S2 equals quote A, end quote, and then I write an if statement like this, if S1 equals S2, there's a possibility that it would say that's true. But there's no guarantee. Absolutely no guarantee. Now what happens is that the Java compiler, when it's going along, will probably notice that these things are the same variable. I mean the same, literal, same value. And so it may have 2 references going to the same place in memory. But you're never sure. Like if we asked the user to type in a letter and we wanted to see if they typed in A, we better not do if S1 equals S2 or if S1 equals A. You just can't use double equal to compare reference variables, regardless of whether that reference variable is a person, a rat, a car, a string. You have to use dot equals to compare strings. Like this. If S1 dot equals parentheses S2, then do something, right? System.out.println the same. System.out.println, not the word line, and I'm sorry, when I'm reading the text off, I often say print line, but it's just println. S1 equal S2. But that's kind of lying, right? That's not actually what it does. If you want, you can provide a method for your object, for your class, that actually will do this comparison. They did not provide that method for the string class. But we could do so. We could do that so that if we checked to see if those objects are the same, it would print true. They are the same. And that's when you add a dot equals method. And the dot equals method needs to check. It needs to check to see if the names are the same and if the age is the same. So I'm going to scroll up here and I'm going to add that. So I'm going to add a method. I'm going to go ahead and be a good boy and say that it's a public method. Public equals, and it takes another person as its parameter. So person space other. It's a reference to another object. And I forgot to make it Boolean. Public space Boolean space equals. Remember, every method we define has to have a return type, or the word void if it's not going to return anything. Then it has to have a name. Then it has to have parentheses. And the stuff inside the parentheses, if any, is a parameter list, a list of variables and their data types. Okay. Now here's what I'm going to do. If, parentheses, this dot age not equals other dot age, end parentheses, return false. Right? Because if the ages are wrong, then they're not equal. Lastly, there's going to be a return true, right? We're going to add another condition, but if none of the conditions that prove it false are there, it's going to return true. Right now it's only checking age, but it should say that P1 is equal to P2 at this point because the ages are the same. And I better stop and wander around because I never trust that people are going to wave their hands and get me to help to type. All right. I was hoping it would say that they were the same. P1, P2. Oh, that's, what have I done?
Called it yet, have you?
You're right, I haven't changed it. For a moment I've looked into C++ where once you define that method, you can actually call equal equal. Let's rewrite this a little bit and make it a little bit less cryptic. We're going to go ahead and use dot equals. So, if P1 dot equals, thank you for saving my butt there, Lynn, P1 dot equals P2, then system.out.println, which I'm just going to copy from that statement because I'm lazy. System.out.println copy. Come up here and paste. P1 is the same as P2. Else, parentheses in parentheses, I'm going to copy that again. P1 is not the same. Now you may know that you don't have to include curly braces if it's only one line of code in the block. So again, since screen real estate is at a premium up here, I'm going to remove those curly braces. You don't have to. And indeed, it says that P1 is the same as P2. Now the criteria it's checking is only age. It's not checking names. But we can fix that. We're going to go back up to the equals method and have it check names as well as age. And there's a specific reason that I'm structuring it like I am. You could word it like this. If this dot age equals other dot age and name dot equals other dot name, and you could keep writing, and, make it, longer and longer and longer. By the time you get like 6 or 7 or 20 different member variables, that if statement's going to be incredibly long. Instead, I think it's easier if you structure it like this, where you just have a series of if statements. And if they differ, you return false. You keep ruling them out, and if none of them are ever different, if it gets to the bottom of the method, then we can return true, indicating that they are the same, that they equal. So let's check to see if the names are equal as well. If this dot name dot equals other dot name, but that's not good enough, right? Because that's going to tell us true or false whether it equals or not. And I told you I wanted to rule it out. So I'm going to do that and then say equals false, right? And there are other ways of expressing that. But if you check those two things and it's not true, then you want to return false. Hope that makes sense. Whatever logic you want to follow is fine. You just want to make sure that it returns true if all the data elements match each other. There's one more check we could put up at the top, which is to see if the this reference actually is the other reference. And when would that be? That would be if you call dot equals on itself. If P1 dot equals parentheses P1. If that was the case, you don't even need to check all this stuff. You know they are the same thing. So that's a little bit wonkier, but I'm going to go ahead and add that check. If this equals other, return true. That kind of makes sense. If you're passing in another object that has the same address as this object, then they really are the same object, right? You really do have one house with two signs pointing to it. You really do have one piece of information with two references to it. Or maybe it's the same reference. But there's no reason to do all these checks if they're pointing to the same object. That's what that's checking for. Maybe we ought to even add a comment here. Are they the same object? Question mark. And then this one would be ages don't match. And the one underneath that one would be names don't match. Now that we've added name as a condition, when it runs, it's still going to say that they're the same, right? Because they're both named Fred and they both have the identical age, but we could change one or the other and then it would start saying that they're not the same. Right? P1 is in fact the same as P2. So let's go. Now I've forgotten what that is. Oh. I actually wanted to delete that line. I think. I'm going to get rid of that check. It's kind of confusing and not well laid out anymore. All it's doing is pointing out whether they're the same reference or not. And we're now checking that up there. So I'm going to get rid of that one. Well, let's change a piece of the data. If P1's named Fred, let's make P2 equal to Joe. And now it's going to say they're not the same. And that's what we want. Or if we change their ages, they will say that they're not the same.
Could you go back up to the
Uh-huh.
person class a minute?
Yeah, let's stop for a moment.
So the return false is after.
I've just noticed that we're getting little comments, these warnings over here. This if statement is redundant. Well, let's see what it has to offer as a fix. Well, what do you want to do about it? Okay, yeah, sure. It was redundant, but if we added more elements, like if we added, their address, and we needed to check their address, then this would really be a bad structure. So I'm going to undo that. Are there any others? It seems like the only, well, here's one. Invert the if. Well, that's ridiculous. What did it mean when it put the exclamation point in front of that?
It does not equal P2.
Right. Yeah, these are no longer equal because that's a Boolean reversal. So if this equals true, it turns the expression into false, and vice versa. So when it put the not there, it also swapped the messages. And again, I don't even know why it thinks that that's a good idea. So I'm going to undo that change as well. So if anybody has their notes, and, whoops, wrong one. And if you wrote down, professor's rules of making classes, can you remind me what I said there so that I'm reiterating them exactly? Because otherwise I'm going to make them up.
From last term?
From the lecture,
From
right, class lecture. I'm happy to make them up, but I just hoping that I get the exact same ones.
you had data, make data private,
Okay, make data private,
make methods public,
make methods public.
use a constructor if it makes the
Okay,
class easier
add
to
constructor if it makes the class easier to use.
use, and use a two-string method so you can display information.
Yeah, add a two-string method to display information.
That's all I got.
Okay, and I'm going to add on a couple more. Make the name start with a capital letter. You're just supposed to do that. I didn't make that rule up. Just the people who invented the Java language said that, and everybody's obeyed it ever since. So that's why I did class person rather than class person. And really fundamentally the reason for doing that is just so that when you're looking at code, if you see something with a lowercase letter in it, you know it's a variable. If you see something with an uppercase letter, you know it's a class. All right. Make data private, make methods public, add a constructor, add a toString, make the name start with a private letter, and add a dot equals if you need to compare objects. Now we haven't done all of these. Which ones have we not done?
Done constructor.
Yeah, we haven't added a constructor, a custom constructor. We haven't made the data private and the methods public. I think that's the one that I'm going to do now. And you can do it the long way or the cheaty short way. The long way is to come up here, type in private here, private there, and then fix all the errors you get. What are the errors? When we use those variables. These are now private, so we can't access them directly. We would need to add getters for that. We'd have to add p2 dot, and setters, p2.setName, and things like that. We could do that. Maybe let's add one of those, but then let NetBeans do the rest. Okay, so since we have int age there, I'm going to go ahead and do a set age. It needs to be public, but it doesn't need to return anything. So public void set age, parentheses, int space age, curly brace, close curly brace, and between the curly braces, this dot age equals age. Right. Now we can go back and fix the errors that have to do with age. So this is what's known as a mutator, because it mutates it. It mutates the value. It's a changer for that. So I'm going to scroll down here. I still hear people typing, so I'm reluctant to scroll away yet. It's okay if you're typing. Don't stop just because I said that. All right. So instead of P1 age equals 30, since this is a private member, it's no longer accessible. So we're going to make it say P1 dot set age, parentheses 30. And we're going to do the same thing down here for P2. P2 dot set age, parentheses 30. And we ought to do the same thing for name, but like I said, in the interest of saving time, we're going to let NetBeans encapsulate them for us. So after you've made those changes, scroll back up and highlight private int age and private string name. And we're going to let NetBeans do it under the Refactor menu. Refactor, encapsulate fields. What encapsulate fields does is it makes the fields private, but it adds getters and setters. Now some of them were already made. Set age was already done. I guess that's why it's got a red mark there, right? But if I click OK, or actually Refactor, then it adds the other methods. And it puts them in weird places. It puts them at the top of the class rather than underneath the variables. If you care, I like having all my variables up at the top of the class, so I'm going to just cut those and move them to the top of the class, and then I may go back and remove all those comments that it added as well. Cut. You don't have to do that, of course. It doesn't matter what order these things are declared, unlike C++. And I'm going to scroll down here, remove those comments. Good enough. I think I've got it. All right, lastly, I want to add a toString method. And I'm almost doing too much review this time, but it's worth doing. I was hoping to get to arrays. We may get a little bit of arrays in today. All right, so a toString method. Oh, and a constructor if we want one. The constructor's easy. Let's do the constructor. Well, they're both easy. What is a constructor? A constructor is what don't type this, allows us to do something like I said, don't type this, person P1 equals new person. It'd be neat and useful if we could do this. Person 1 is equal to new person, Fred, and he's 30 years old. I want to be able to do that, but I have to provide the class with a way to accept that information while it's constructing the object. So we're going to add a constructor. And a constructor is a method that has the same name as the class and no return type. I may even make that a comment. A constructor is a method that has the same name as the class, no return type, and is invoked by the new keyword to create the object. Let's do it. Better be public or else you couldn't make anything. Public person. I'm going to make a default constructor as well. So the default constructor is not going to do a dang thing. I'm just going to put default there. The reason I'm adding that is so that it doesn't break the code. Because once you add a custom constructor, a parameterized constructor, like we're going to do next, then the P1 equals new and that P2 equals new would then be broken. And we don't want to break our existing code. We just want to make our code better. So I'm going to go ahead and add the default constructor. And now for the parameterized constructor. Public person, and it's going to take two variables. String name and int age. So public person, parentheses, string space name, comma, int space age, open curly brace. Let it go ahead and create the closed curly brace, and now we need to set the pieces of data. This.age equals age. And tell me, guys, if this is good or bad coding. This.name equals name. Is that a good idea or a bad idea? Somebody just take a guess so I can tell you why you're right or wrong.
You said this was a good thing to use because it helps you know that the variable's in that method.
Correct. I'm happy with the use of the word this here and to distinguish that variable from this one. But if I have a string being passed in by reference there, is copying it like that a good idea? It probably wouldn't hurt this time, but whenever you're dealing with reference variables, you should call copy rather than call equals. I'm suddenly blipping on how to do that. I think it's this.name dot. Nope. All right, I'm going to leave that alone then for now. Something's really bugging me about that, and what is bugging me about that is that we have now two references to the same memory, which is okay for strings. All right, I guess I'll just say that at a future point in our coding, we would probably want to create a copy method so that we could copy the data of one object into another, rather than just have two references to the same one. And I keep saying two references to the same one. What do I mean by that? By the way, everybody build this. Oh, I hope I started the recorder again. Yeah, everybody build this, and if you have typos, I'd like to come fix them now before we go on. Now, we didn't change the functionality of the code, right, at least as far as this is concerned, so we should be getting the same answers as we did before. So that's our default constructor, and the next one is a parameterized constructor, which I colloquially call a custom constructor. Parameterized constructor, ACA, also known as custom constructor. Let's go take advantage of the parameterized constructor. We're going to go down in main and create another object using the parameterized constructor rather than the default one. So everybody got this part in? I don't see any nods, no. Okay, so down here where I was creating objects, I'm going to create a couple more. Right? Maybe I'll just do it right after I did Fred and Joe. Scroll down there. Person with a capital P. P3 equals new person with a capital P. Joe, or Bob, we haven't used the word Bob yet. Person parentheses quote Bob, end quote, comma, and Bob's only 15, end parentheses, semicolon. All right. So we were able to do all of that in one line, whereas when we created these objects, we had to do 3 lines. So when I'm giving you my rules, my guidelines, they're not rules. If it makes it easier to use the class, if you like being able to create the object and set the data in one fell swoop, it's worth adding parameterized constructors. If you don't think it's necessary, if you like specifying each data element separately, that's fine. If your object has 20 to 30 to 40 different members for some reason, you're probably not going to want to create a parameterized constructor that takes that many members. There's something else going on there. All right, lastly, I want to be able to print this stuff out. Here's what I want to be able to do. System.out.println, parentheses, P3. And when it runs, it's not going to print anything we like seeing. Here's what it says. Person at 15db9742. You can see what that reference really is. It's just a hash memory address to the object. And when I keep saying we have 2 references to the same object, what if we did this? Person P4 equals P3. Now if I print that one out, let's print them both out. So I'm just going to copy that line and paste it. Print out P4 as well as P3. See what it says. They have the same address. No, they are referring to the same address. They are pointing to the same object. You have 2 signs pointing to the same house. So if we change the name of P4, it's also going to change it for P3. So if I do P4 dot set name to Becky, just to stop using guys, and then we print P3 dot get name, it's also going to say Becky. Just like if you have a house with 2 signs pointing to it and you paint the door blue, well, both signs are now pointing towards the blue door. So system.out.println, parentheses, P3 dot get name, parentheses, in parentheses. Parentheses, run it. All right. And it printed out Becky. Even though that person P3's name was Bob, and we called P4.setName Becky, P3's name would now be Becky as well, because they're pointing to the same object. They're pointing to the same memory. All right, what if we wanted to be able to print the person out and not have it print a memory address? It'd be cool if when I did these printings, it did not print out that memory address, but it printed out their name and their age. So we're going to go add that. Do I need to slow down? Anybody still typing what I've done here? Now, when I go back there and we've got typos here after I asked, naughty, naughty. Okay, let's come up here and we're going to add a toString method. Public string, because it has to return something, to, to, capital S, string, and it has to be precise. Public string to string, capital S in both places, parentheses, close parentheses, open curly brace, I'm curious about something. Let me type something and see if it works. Nah, I didn't think so. All right, but we can do this. Return their name plus a space plus their age. I think I've mentioned this before, but if you have a numeric piece of data, the fastest way to convert it to a string is just to add it to another string. Right? Like if I wanted to create a variable that was age, but it was a string version of it, don't type this, I'm going to delete it. Well, I mean, you can do whatever you want. Right? Is equal to empty quote plus age. That's faster than calling integer.toString parentheses age. Yeah.
Yes, all my code's all.
Okay, let me come help. I think that's enough for me to run it and have it not print those addresses and to print out the data. And it did. That worked. It's wanting to add a little comment here. I'm going to let it do that. You don't have to do that, and certainly don't type it in. But if you see that little error sign and you want to choose the @override annotation, even though we don't know what that means yet, it at least makes the error go away. And I tell you, don't click on those errors if you don't know why to do something. That one's okay to do.